All right, so we're working on the chassis today for this latest vehicle, and I'm starting with the front bulkhead. So the first thing that I need to do is capture the mounting locations for the lower control arm and then work my way out from there. So these are just two simple plates using 1/4" 4130 chromoly here. And the goal for this bulkhead was to tie in the upper and lower control arms to all the suspension mounting pivot points, as well as the center diff and the steering brackets. And so I'm just grabbing the locations of everything here to figure out where those shock mounts are going to live and where the control arm mounts are going to live. And I had considered making this out of billet up here, but the packaging was so tight that plate steel made a lot more sense. But the thicknesses were off on some of the hardware selection that I chose. So I had to make some spacer brackets to get everything to line up properly. And then I just have one center spine tube running through the bottom of the bulkhead. And that's where I'm going to anchor everything off of. And then these other tubes serve a dual purpose. They're going to tie the upper control arm mounts together, and they're going to house the center sway bar, which is mounted transversely and rides inside of bushings inside of a tube on the chassis. Then for the steering, luckily the steering rack that I chose had a really nice flat mounting surface. So I just had to use some reference sketches to capture the bolt hole locations, and then I can start working on the diff. And the goal is to tie that front steering bracket plate into the diff housing plates and just clamp everything from 3 sides. So steering in the front, and then grab the diffs on the 2 sides and then box everything in, because the diff housing itself is chromoly as well. So it'll be really easy to weld that in to the middle of the bulkhead and then the front third member from that diff. So you can still replace it and move it if you need. But I did have some clearance issues on the steering rack. So I needed to use some low profile lock nuts and then add some pocket cutouts to the steering bracket. So then on a part like this, the important thing is that all those plates are easy to cut out so that I could use a laser cutter, and they need to be rigid but also lightweight. So adding some pocket cutouts to get rid of extra material where I don't need it was key on this design. And then by going back into the upper assembly, I can just make a new 3D sketch and grab all the different parts of the diff that I'm going to be interfacing with, and that sets the sketch locations and the planes for the rest of the plate work. But I also have to leave room for a little bit of clearance on the bottom of the diff and that offset hole for the third member for the axle to pass through it, and then just tie the rest of that plate work into itself. So in a part like this, it's really important that it's rigid in all 3 directions. So what I did was I examined it from the top, the bottom, and each side, and the front and the back to make sure that it wasn't going to have the parallelogram effect and that it would be rigid torsionally, vertically, and transversely. So the next thing that I'm thinking about is the lights on this vehicle, and I want it to have a Baja Safari look to it. So I'm taking reference images from Safari 911s, and they have this really cool configuration of lights where they have 2 big lights on the outside and then 4 rally lights in the center. So I had a pre-existing model of a Baja Designs LED pod light and just scaled it up a little bit to make the big lights on the side, and it gave it that classic rally look. And that's sort of going to be my anchor point for the side profile, which I'm working on here. So I'm using a reference image from a Porsche 930 and then overlaying that onto the design to get the wheelbase approximately the same. And then I like to draw out the profile in Microsoft Paint usually to get the profile of the vehicle the way that I want it. And then I can translate that into SolidWorks after the fact. So the next thing that I need to think about is how I'm going to mount all of those shocks on the inboard side of the vehicle. And at first I started to design a piece of billet that was going to grab all the shock mounts, but I ended up doing away with that design and just making it out of sheet metal instead, because this billet part ended up looking a little bit blocky, and it's right in the middle of the cabin by the driver's knees. So I didn't really love that design. And it's difficult to bolt a billet aluminum part to chromoly tube because you have to clamp it. There's no way to weld them together. But this is what that first design looked like for a billet shock mount. And then we'll end up redesigning it out of sheet metal in the end. So here's the shock mount locations being redesigned out of sheet metal. I decided to just tie in some simple plate work into the pre-existing tubes, and it ended up being a lot tighter packaging and a little bit more of a sleek design. So this can all just be fabricated as one part with tube work and plate work, and it'd be pretty straightforward to make. Then I just need to copy the hardware over and shorten those bolts. And then the front bulkhead is all tied in with all the front suspension components, including the push rod, the sway bar, the shocks, the heave spring, and the upper and lower control arms, as well as the center diff. And I really like this design because it allows for a really good anchor point for the tube work that's going to make up the windshield portion of the chassis. And then since these were offset a little bit, I decided to go with bent sheet metal that will tie into the tubes at their strongest locations and then box that in so that it's really rigid laterally. So the next thing I need to think about is the front push bar of the vehicle. And I want to have a big bumper that reaches out and around the wheels. So the first thing to do in the upper assembly is put the wheels at full compression and full lock to make sure that the tube work is going to clear the tires as they cycle through suspension and steering, and then tie everything in with some tube work. But I need to be careful about how I set these weldments to make sure that I have the longest length runners in the tubes so that I can bend them in place and then gusset them with support bars. So now we can start making the profile sketch for the chassis. And I want it to have a Porsche 911 shape to it. So I'm just starting in the upper assembly and drawing a sketch in the context of this top assembly. And then I can transfer that sketch into subsequent parts and build a chassis around it. But it's really important to have the cabin dimensions correct and all the mounting locations for everything that I'm going to tie it to, which includes the front bulkhead and the rear bulkhead. And then can make sure I have a really nice hood line as well as a cabin A and B pillar that are going to work with all the stuff jammed in the middle, like the seats and the engine, and then also leave clearance for the driver's head with a helmet and make sure that that firewall is far forward enough where the feet are not going to hit. And then for that top arc, I want that to be a round number so that I can send it through a tube roller and bend it to a really large radius, and then just have one continuous hoop that runs along the top roof and the back of the vehicle to give that Porsche shape. And I think that's going to look really nice. So before I finish the profile design, what I need to do is make a wing because I want to have a big GT3 style wing in the back. And I want to make sure that the aesthetics of that wing are going to work with the rest of the vehicle. So I'm just drawing a side profile with a couple of radiused arcs. And then I have a dual plane wing with some side skirts on it on either side. And I wanted those side planes of the wing to have an airfoil shape. And I ended up wrestling with this quite a bit because it has a parallelogram shape to it. So I couldn't get fillets and chamfers to work on it. So I ended up just putting a radius on that leading edge and then doing a cut along the back to give it sort of an airfoil shape. But I wrestled with this for a long time because it kept airing out, but finally got it the way that I wanted it and then dropped it in the upper assembly to see how that profile looks. And it's starting to look really great. So now I can start actually making a 3D sketch for the chassis, but it's really important to have clearance for those front wheels so that the cabin portion of the chassis doesn't interfere with the tires at full compression and full steering lock, but still has enough room for the driver's feet. So that's what I started with, was that bottom floor pan. And then I just need to adjust some dimensions on that B pillar of the cabin to get everything to tie in correctly. So this was kind of a tricky part of the design because I was editing a part in the upper assembly. So all the other parts in the upper assembly were transparent and it was hard to tell what was what, but I needed to do it in this view so that I could get all the tubes pointed in the right direction so they're not going to interfere with the engine or the seats or the shocks. And I actually ended up mirroring one of these shocks just to get those bypass tubes to be pointed outboard to give me a little bit more room for the B pillar. And I want the greenhouse of the cabin to angle in a little bit at the top to give it that distinct Porsche look. So the bottom of the floor pan was a little bit wider than the top of the roof so that the A and B pillars would be angled a little bit, but still plenty of room for the driver. And since those pushrod mounted shocks had really tight packaging, what I ended up doing was making a secondary B pillar. So there's one B pillar that goes from the top of the roof down to the bottom of the floor pan. And then right in front of that, there's another one at a slightly different angle. And that sort of forms the window of the greenhouse. But then the primary B pillar will attach to the back of the seats and we'll have a belt bar running laterally that will tie everything in. Then I just need to tie the cabin chassis into that pivot bar where the sway bar lives. And that's the same bar that houses the push rod arms. And that's sort of the anchor point for the rear of the chassis. And then I just need some bars running all the way backwards along the rear underneath the engine. And then I can start adding in the weldments. So I decided to go with 2-inch tube, 120 wall thickness on the entire vehicle here. That seemed like a really nice, strong tube selection. And that extra strength allows me to have less tube work than on the rock bouncer design or anything like that. And the chassis is starting to come together. So I can just mirror that over to the other side and then finish up all the tie-in points for everything. And then the front of the bulkhead, I'm just tying in those hood arcs into the bulkhead tube work in a really simple triangulated way so that it's extra strong and extra rigid in that area. So I found the way around that strange transparency view that I had editing a part in the upper assembly. I just set the whole view to wireframe, which changed the parts from transparent to black and white, and that made it a lot easier. So then on the rear of the chassis, I have 3 things that I need to tie in. The shock mounts, the rear Y trailing arm outboard mount, and the inboard mount as well. And also the engine mount. So this would have been a lot easier to make this out of billet, but I wanted to challenge myself to try to make this all out of sheet metal to make sure I have something that's fabricatable and is plenty strong. And it turned out to be kind of tricky because all these parts are at weird angles with respect to each other. So I went through a couple iterations before I landed on a set of plate work that I was confident in, and it would be easy to box it in during fabrication. But at first pass, I didn't like the shape of this. I thought it was a little bit too simple. And the majority of the stress is going to be on this back part of the vehicle because all the shock loads are going through that one part, and the driving force from the wheels are going to be pushing into the chassis via that anchor point. So I thought tying the engine mounts into the suspension mounts would be a good way to combine components in a way that makes sense. But I had a hard time tying the tubes into that the way that it exists as you see it. And also the other challenging part was I started on the wrong side, so I made a mistake. I had to mirror the part over and work off of one mirror and then edit the other existing part. So it was really hard to use reference geometry to get these right. I should have just deleted it and started over on the correct side rather than working off of 2 sets of mirrors. But then once I had the tube mounts sort of where I wanted them, I just needed to check clearance on the drive shafts and leave room for the fuel tank. But luckily there was plenty of room back there. So just a couple of tweaks to the 3D sketch got that to work. So here we are starting on that second iteration of the shock mount and decided to tie it into the chassis at the furthest point forward possible and then box everything in from there in a way that would leave lots of room for extra tube work and leave clearance for the drive shaft, which was passing right between those components. So I'm boxing this in on a similar style that I used on the trophy truck because this is going to be the most prominent piece of tube work and plate work. You're always going to be able to see this. And it really highlights the fact that this is a push rod suspension vehicle. So I just needed to add some tubes to tie that front shock mount into the front and middle of the chassis. Then on the engine mount, to have clearance for the drive shaft, I had to have a big U-shaped tube to reach out and around the drive shaft and sort of protect it, but also tie it into those chassis bottom rails. And that simplified the design of the rear pivot mounts significantly. Then I can add some really cool triangulated plates to constrain everything in all 3 directions. Now that the rear shock mounts are in, I can fill in those gaps with tube work and drop in the drive shafts and check the clearance. And I just needed to adjust the angle of that transfer case to get it to not interfere with the tube and then fix some of the mates in here. And now that those drive shaft components are in and the entire drivetrain is complete, the chassis is complete, the suspension is complete, and this vehicle is done.